Good morning to all the respected professors, my fellow classmates, and everybody present here. My name is Babita, student of BTech 8th semester Aeronautical Engineering at University Department, Rajasthan Technical University, Kota. Today I am here to present topic of my seminar presentation on Parker Solar Probe under guidance of Sir Anshul Khandelwal. So let's start with the first slide. These are the contents that I am going to start to cover. Firstly, introduction to the Parker Solar Probe. Parker Solar Probe spacecraft is a NASA spacecraft that launched in 2018 to explore the Sun's atmosphere, corona, and collect information about high-speed energetic particles moving out of the solar wind that affects the Earth's magnetosphere and the space weather. The mission was planned for 7 years. During the journey, it was approached the Sun at 9.86 solar radius from the center of the Sun and will travel at a speed of 6,90,000 kilometers per hour. The mission was using 7 Venus flybys for 7 years to gradually reduce its orbit around the Sun and complete a total of 4 solar encounters. The spacecraft will come 3.8 million miles closer to the Sun within the orbit of Mercury. The environment around the Sun has a high temperature, so to protect the spacecraft and the instrument, a 4.5 thick carbon composite is used which will withstand the temperature of 25,000 degree Fahrenheit at its closest approach to the Sun. Now the properties of the spacecraft are: mass of the spacecraft is 685 kg, height of the spacecraft is 3 meters. Solar array in the spacecraft can produce 388 watt of power. Spacecraft has 2 solar arrays. Mass of the temperature protect system (TPS) is 73 kg. Now the science objective. There are scientific objectives of the Parker Solar Probes are to study the flow of energy that accelerates corona and solar wind, determine the structure and dynamics of magnetic field, explore the mechanics that accelerate and transport energetic particles. Now the instruments. Solar Parker Probe is carrying 4 instruments to study magnetic field, plasma and energetic particles and image the corona and the solar wind. They are: first, field, whisper, sweep, ISIS. Now the field. The field instrument suits capture the scale, shape of electric and magnetic field in the Sun's atmosphere. Field measurements wave and turbulence in the heliosphere. Now whisper. The whisper is the only image instrument in the spacecraft. Whisper look at the large-scale structure of the corona and the solar wind before the spacecraft flies through it. Now, sweep. This instrument counts the most abundant particles in the solar wind, like electrons, protons, and helium ions, and measures properties such as velocity, density, and temperature. Now, ISIS. By measuring electron, proton, and ion, ISIS will understand the particles' life cycle, where they come from, and how they become accelerated, and how they move out space from the Sun through interplanetary space. Now, launch. So, Parker Solar Probe launch phase was similar to the other interplanetary mission, first being placed into an Earth parking orbit and then being injected into the required heliocentric mission trajectory. The launch energy is much higher than most interplanetary missions and requires a powerful 3-stage launch system. The maximum launch energy required for a 20-day launch period is 154 km square per second square. So the probe was launched on a Delta IV heavy rocket with Star 48B solid motor. Now trajectory. The Parker Solar Mission trajectory used repeated gravity assist at Venus to increase its orbital perihelion to achieve a final altitude of approximately 8.5 solar radius. The mission is using 7 Venus flybys for 7 years to gradually reduce its orbit around the Sun and complete a total 24 solar encounters. This image shows the trajectory of Parker Solar Probe. Any questions?
Yes. Why Parker Solar Probe does not melt?
Parker Solar Probe have been designed to withstand the extreme conditions and temperature fluctuations for the mission. It make use of heat shield known as thermal protection system. Thank you.